I'm Sungchul, Assistant Professor at Kansas State University. I'm going to present a research on the use of multisensory cues in symmetric and asymmetric shared collaborative virtual space. It is still unclear if additional communication and the collaborative channels are always beneficial or not in communication or collaboration. As an example, Fussell investigated the performance of asymmetrical collaborative workspace with audio, video, or audio-only communication channels. And they found that concurrent video communication might not be superior compared to on audio-only channels in terms of adequacy. Similar questions also arise in the area of virtual reality technology-based collaborative space. For example, imagine that you are having a business meeting with your collaborators in a moving train. You might want to open a side window, for example, to cool down the temperature in the train or to take in some fresh air. It is a natural expectation to feel the cool wind blowing. The rumble of the train beneath your feet and maybe even smell the lavender field the train is running past. Imagine the same train idea, but without feeling the vibration, wind, and the smell at all, though other passengers still feel them. Or imagine you can sense the stimuli, but your colleagues seated across from you in the train cannot feel them at all. What would this be like? How would it be impacted your collaborative interactions? Would this influence your emotions or decision-making abilities? Individuals can have different system configuration with different level and kind of immersive sensory technology. We anticipate that perceptual information imbalance between the future VR users could be a serious issue as our society has already observed the impact of perceptually unbalanced information previously in the case of TVs, for example, cable, satellites versus broadcast, or a smartphone like a high-end versus low-end. This technical platform shows great potential as a next-generation communication and collaboration platform due to the high level of immersion. To investigate this topic, we simulate the anticipated future VR scenario and conducted preliminary researches. For deeper understanding regarding the impact of symmetric sensory channels between VR users, using the train scenario described above, we conducted two independent studies, one with a symmetric VR system and one with an asymmetric VR system with two levels of sensory cues, multi-sensory VR and typical sensory VR in each experiment. Also, we varied NPC, non-player controls, reaction. We collected data in terms of in-game score, perceptual response, participant emotional responses, and enjoyments. We generated flow vibration using four low frequency transducer attached underneath a raised floor that we marked the location with blue square shown in this image. To provide an acceptable level of vibration intensity, we selected choose valued in the range of 1.2 G to 1.4 G, which is equivalent to the vibration generated in mild driving conditions. We provide the wind feedback via a setup of 8 DC burst series fans. We control the speed 0 to 255. We use the formulated essential oil and an aroma diffuser USB stick to deliver smell feedback. This image shows the overview of the experimental setup. In the VR environment, the pair of participants was asked to imagine they were on the curb manager for the new software tour, trying to assess the quality of the tour stop sites. When the train stopped at an attraction point, both subjects had to rate the quality of the attraction point on a 1 to 5 scale, where 1 was bad and 5 was excellent. The NPC has idle behavior and ambient conversation noise in general. In the yes condition, they had active behavior and the voice tone changes when the train stopped at each attraction point. Otherwise, In the null condition, the NPCs simply stay in the idle state. With symmetric system configuration match, we conducted the study with 8 pair of male subject and 4 pair of female subject for a total of 24 subjects, but we did not find a significant difference. With a asymmetric system configuration match, we conducted the study with 5 pairs of male subject and 5 pairs of female subject for a total of 20 subjects, but we did not find a significant difference. We retrospected the study during record the video regarding the result. Through the video, we observed that if personality and the relationship between the pair may impact the result, since the pair of the participants had to communicate, and then we also observed that their characteristics sometimes overact over the rating, the quality. Using two human intelligence, we categorized the character into 3: assertive, passive, and aggressive. In this follow-on analysis, we found significant difference in characteristic and relationship for in-game, system type and characteristics for presence, system type for social presence, system type and relationship per and system type for enjoyment. We also found a strong tendency in characteristic and relationship for co-presence. However, the effect size in the result were classified with Cohen's convention as a trivial effect size. The follow-on analysis in the second experiment, asymmetric condition, we found significant difference in characteristic and the relationship for presence and the relationship for co-presence. We also found a strong tendency in system type and characteristic for in-game. However, the effect size in the result were classified with Cohen's convention as a trivial effect size as well. As we mentioned, we have an important observation in this study that was the impact of a communication style. During the study, we frequently observed that different personal characteristics and the relationship influenced the communication, and the communication style could have an impact on the rating process, as well as subjective feeling. Regardless of the added independent variable, the multisensory VR experience shows the highest mean value compared to the typical sensory VR experience for the given dependent variables in general, in both symmetric and asymmetric experiment. We do not claim this statement strongly, since this finding was based on additional exploration of the data, and this led to unbalanced sample and low effect size, and thus the power is weak. However, we strongly suggest that VR researchers and the designers consider these factors for shared VR experience. We found that multisensory VR system shows a strong tendency toward providing a fun entertainment or wow factor due to the improved realism of the VR experience compared to a typical VR system. Also, participants shows more solid consensus in their decision in the symmetric VR system than the asymmetric VR system. Another potential problem was that we might need to find acceptable threshold to deliver the additional sensor feedback such as vibration, wind, smell, and others. We conduct a pilot study to measure and see the detectable and acceptable level of each sensor modality, and thus we confirmed that delivered sensor feedback was unacceptable level in this study. However, some participants could not perceptually detect the sensation well, depending on things like the crossings or they were or their body condition. We investigate impact of the multi-sensor VR system on the symmetric and asymmetric sensor modality system between two immersive users. We strongly recommend that researchers and developers in the computer-supported cooperative work and social computing communities carefully choose and design sensor modality they provide to user and take into account personality trait for multi-user collaboration tasks when immersive VR technology are involved. Thanks for your listening. If you have any question or comment, please join my session. Then we will have a time to discuss. Thank you.